You can go pick your binder up. I already went through them. I've got the grades. I'll post the grades online later, so it doesn't show your grade in there. Yes, I'm going to put them all on the computer. I'll give those back next time.
Okay. If you would have asked, I have sticky notes.
Or, yeah, well, not everyone had those papers in there, but I wrote them down. It's good. Last time when I did the sticky notes, I had my computer on, so I was able to put the grades in as I was going. Anyone else want to turn in this little participation / graded quiz? Thank you. Just a little extra couple of points. Yeah. Are y'all working on the first one or the second one? Okay. All right. Well, turn in what you've got. I'll look at how far you've gotten on that one, but I need to continue. We still have some time here, so. Got the first one though, right?
Yeah.
Okay. Names on it. Okay, so from the looks of it, most of you got the correct answer for the first one, which was what? Negative infinity to negative 5 halves, or negative 2.5. Union negative 5 halves to, do you remember? Was it negative 2? And then union negative 2 to infinity. That look right? I'll do this. Well, that's the domain. You still have to find the composition, which I'm not going to go through. But x was getting plugged in. It was spitting out 1 over x plus 2. Is that what you got when you did the composition?
Yes.
So from here to here, x cannot be negative 2. But from here to here, 1 over x plus 2 cannot be equal to negative 2. And so that's the part you have to set up and solve. And you should get, what, 5 halves, negative 5 halves? Okay. Now, there's one more idea that we need to talk about in this section. And this next topic is used in Calculus 1. And so you'll probably see it here and you won't see it again until Cal 1. But it'll become very, very useful in Calculus 1. So this has to do with decomposing functions. Let's say we're given a function like this. I'll call it capital F of x instead of little f equals square root of x squared plus x plus 1 over x to the 4th. You know what? Hold on. I think that's a little too much right now. Let's just do this. X squared plus x plus 1. So what we're going to do here is we're going to try and work backwards. We're going to take a look at capital F, and we're going to see if we can rewrite capital F as the composition of two functions. So I want us to write capital F of x as the composition of two functions. So what this means is that you want to look at this function here and try and see that it is a function inside of another function. That's what we're looking for. Can you determine that this is a function inside of a function? Yes or no? What do you think? Yes? Okay, so when we talk about functions, we look at them as like layers of an onion. We have an inner layer and an outer layer. So what's the outer layer of this function? The square root function, right? What's the inner layer of the function? The quadratic function. You see that? So this looks like, in the order of things, that you have a quadratic function inside of a square root function. Yeah? So what we need to figure out is how we would define f of x and g of x so that if we put them together with composition, we would get this. So you said the outer function was what? Square root function. And the outer function, according to this, is the f or the g. The f is the outer function. So my f function needs to be a square root function, doesn't it? And the inner function, the part in red, needs to be the quadratic function, right? Exactly. Now, if you take this composition, if you take this, and I ask you to do this right now, right? If I were to ask you to do this, you would take f, inside you'd plug g. But what would g be? This x squared plus x plus 1, you'd take that and you would plug it into f. So you plug this whole thing into f and you would get the original function, wouldn't you? Okay. Now, excuse me. In Calculus 1, what we're trying to do is take a, man. I'm just kidding. Everyone would be like, yeah, we're going to get out early today. In Calculus 1, what we're trying to do is take a rather complicated function and break it down into simpler functions. Do you agree, like, if I asked you to graph this, you would actually scratch your head, hopefully, because we've never graphed anything like that. Right? You got it? But if I asked you to graph this and this separately, could you? Yeah, square root of x, that's one of your toolbox functions. Everyone needs to know what it looks like. This one is a parabola. We all know how to graph those. So in Cal 1, what we do is we take a complicated function, break it down into its smaller basic pieces, and then we do something to each of those pieces. So it's kind of like the idea of divide and conquer a little bit. You split it up. You make each piece easier. You do one at a time instead of trying to tackle the big thing all at once. So let's try another one. The answer to this problem would have been this, right? Right here? That's the answer. That's it right there. Let's try a different one. How about this? Given h of x equals, see how you do with this. 1 over the square root of x squared plus 1 all to the 40th power. I would like us to break this down into simpler, a composition of simpler functions. But I'm not going to tell you how many. Like in the last problem I said, write this as f of g of x, right? In the last problem? Which told you that there were 2 layers to it. On this one, I'm not going to tell you how many layers. I want to see what you can come up with. Like how many layers you see in this. That's the layer right there? That's the layer? You could, and you would not be able to do much in Cal 1. But I mean, that's what would happen if you couldn't break it down. So let's see, what's the most number of layers we can get from this? So the way I like to look at the onion part is you start by acting like you're a value of x. Like plug in a value of x, right? Order of operations would be we'd square it first. And then we would add 1. Then we take the square root. Then we'd divide that into 1, and then we'd raise it to the 40th power. So now let's work backwards now. What's the last thing that happens? The 40th power. So do you agree that we have a bunch of stuff to the 40th power? So that's a power function. That's x to the 40th power. So I'm going to let my outer layer of my onion be x to the 40th. You can have, people can have different variations of answers here. It's not a unique answer. So what? Okay, so now what you're seeing next is the next thing inside, because we've taken care of this, is you're seeing that it's 1 over something, right?
Well, like what I did first, was the all of 1 over x to the 40th on the outside. And then.
Oh, that was your first function. So you did, yes, you could do that. That would be a little different than what I'm doing, but yes, you could. I'll show a different variation of this answer in a second. Yes?
So I was going to see if the next one.
Yeah, what do you want for the next one?
G would be x, the root of x.
Root of x, okay. Almost. 1 over the root of x. You could do that. And the next one down, what do you want to call it? Little h. Can't use capital H. Capital H is already being used. Would have to be what? X squared plus 1. Do you agree with this? If I take x squared plus 1 and plug it in right here, I would get 1 over the square root of x squared plus 1. If I take that answer and I plug it into here, I'd get that. So this is actually a composition of 3 functions. This is f composed with g, yes, composed with h of x. If you were to do this composition, you would get back the original function. Your ability to swim or sink, whether or not you swim or sink in Cal 1, is very much determined upon your ability to break a function down like that. That's not the only way to do it, though. It's not a unique answer. So I heard, is there a way to do it with 4 functions? Absolutely. You could do it with 4. Let's see about how we could do it with 4. I'll do it in a different color. So what do you want the outside function to be? Still x to the 40th? Sure. That's the last thing that happens. Now g, we had used 1 over root x. You want to use something different? Just 1 over x. And then h, you want to be the square root of x. So let's just see the slight difference between these two so far. This one, 1 over root x, right, was all kind of, you got the fraction and the root all in one function. Here we split it up. 1 over x, but what's x going to be replaced with? The root. So when that root goes in here, you get the 1 over root x. And then that answer goes in here to get to the 40th power. What we still need is one additional function, which would be the x squared plus 1, which I should probably use what? Like h. We usually don't use I because of the imaginary number, so we go to j. So j of x would be x squared plus 1, right? It can be x squared plus 1. And now if I take x plus 1 and plug it in here, I get square root of x squared plus 1. If I plug that into here, I get 1 over the square root of x squared plus 1. If I plug that into here, I get 1 over the square root of x squared plus 1 to the 40th power. So this composition, this into this into this into this, will give us the same thing. So this would be what? F of g of h of j of x equals h of x also. Exactly. Whatever. Could I have gotten, what, 5? Got this in 5 functions? I could have. I could have changed this x squared plus 1 to an x plus 1, and then k of x, x squared. So x squared goes into this. That goes into this. But look at, check this out. This is actually a super efficient decomposition of this very complicated function, because look, do you know what x squared looks like?
Yep.
Yes, parabola. Do you know what x plus 1 looks like? It's just a line, right? Do you know what the square root of x is? Yeah, it's just the square root. 1 over x, that's a rational function. It's one of the ones I showed you in the very beginning. It was a very important function. We did look at that. And then x to the 40th, well, that looks like a parabola, right? That's a polynomial. Both sides go up. I mean, you know what each one of these individually looks like. So in Cal 1, that's the approach. Divide and conquer. I think that is kind of a good stopping point. I hate to cut class short anytime, but you should be able to handle the homework on the syllabus, on the schedule. You should be able to handle that homework for 6.1. 6.1. Everybody have a great day. I'll see you. Oh, wait, Wednesday we don't have class. Wednesday is a holiday. Not a holiday for you. It's not a holiday for me. Wednesday is a holiday, so no class Wednesday. I will see you next Monday. All right? It's Faculty Development Day, so it's an employee day that we don't have classes. If you have a class after 5 p.m., it does meet. So classes after 5 do meet. Sure. Send me an email or something.